Hi guys, welcome to my project box. Here in my hands I have the infamous Sonoff Mini smart switch, and all your Sonoff fans should really be familiar with it by now. It's a great little smart switch. It requires both a line conductor and a neutral connection to function properly, to power itself. Now that's great if you've actually got the neutral connection behind your light switch box. Now I know this is not the case in many places. Certainly I've encountered this, that the neutral is not always available. Now it's okay if you can actually pull the neutral connection through to the switch, and then you can power it that way. But sometimes it's just not possible to use it. Now I know on the market there are no neutral smart switches available, but I really wanted to try and see if it's possible to power the Sonoff Mini behind the light switch without a neutral connection, and I think it is. I think it's a little circuit hack, a really simple little circuit hack that we could do that allows us to put this behind your light switch. And you don't need this neutral connection, just the line in and switch line out. And I think I found a simple way to do it. And the great thing about this hack is it requires no soldering, just a few passive components and a terminal block. So I'll share with you how I did it, and you can try this yourself. Let's take a look at a Sonoff Mini wired to work without a neutral as an example. As you can see, there's clearly no neutral wire connected to the Sonoff Mini. But it still works. Let's test Google Home voice control. Turn on the outside lights.
Got it. Turning the outside lights on.
Turn off the outside lights.
Okay. Turning the outside lights off.
In this diagram, you can clearly see that all you need to make this work is 4 diodes and a capacitor. And I'll show you in depth how this all works a bit later in the video. But for now, you can have a quick look to see how it's wired. And now I will show you how to put it all together. So in order to do this particular circuit hack, all you really need is 4 of these diodes. And to do it properly, you need a capacitor as well, and of course the Sonoff Mini. Now I really wanted to have something here that you don't need a soldering iron, because in my previous video I did something similar, but I made a circuit board and I soldered everything. So I wanted to try and make a video where none of that is necessary. So all these components are just going to be twisted together and put into terminal blocks. And as you see, it's dead simple. So what we need to do is to start off with is start by taking 2 of these diodes, and we need to point one in the up direction and one in the down direction, and then we put them at an angle like so, and then we simply twist them together. And there you go. This is the bit that's going to go in here. So that's the bit for the Sonoff. And then we do the same thing again. 1 diode pointing up and 1 diode pointing down, and we twist them together. And you don't have to be terribly neat. You can solder them if you want, but for those of you who don't like soldering, this might be for you. And now, this is where you have to look at polarity. The capacitor has a positive and a negative. So the stripy side here is the negative, and the diode that points away from it is going to be twisted onto that leg. So what we'll do is we'll put this one to the side and we'll twist these ones together. And then we'll neatly bend it over. And then we'll twist these ones together. This is effectively creating the light bulb bypass anti-flicker unit. And then we can crop the leads a bit shorter, just to tidy them up. Now, this is going to go into our bulb. And for simplicity's sake, we'll just show you them going in, but you can put some heat shrink sleeving around it to insulate it. But these just simply go in there. And this will go in our live out to neutral in. So the diodes point from live out and join together, and then the other diode points to neutral in, and that just goes onto there. There you go. That's simple. This is our bypass unit that goes by the light bulb with smoothing capacitor to get rid of any unwanted flicker in our bulb. So as you can see, no soldering necessary. Now we just need to add terminal blocks to terminate wires onto these diodes. And then our terminal block can just screw onto there. And our terminal block goes onto here. That's it. That's our full no neutral circuit done. These components cost peanuts. They're very cheap. I think it's a couple of cents for the capacitor and the same for the diodes. This must be one of the cheapest hacks you can do with your Sonoff. So let's wire the Sonoff Mini up properly, terminate all the wires into it, and then stick some power onto it to see how it works in real life. So we start by first putting the line in into the line in input terminal of the Sonoff Mini. And then we have our diodes pointing up and down, and they go into the switched out of the Sonoff, the line out, and the neutral in. The next wire to connect is what would have been our switch live out from the light switch. That now via terminal block connects to the two diodes. Next we connect our light switch to the S1 and S2 terminals on the Sonoff Mini, which will now act as the light switch. These terminals aren't mains powered, they're a low voltage trigger for the Sonoff. There's no high voltage passing through them. Now we need to connect up our lamp bypass / anti-flicker unit to the lamp base. Next we connect the neutral wire to the capacitor's negative terminal. And now the two terminal blocks get connected together. This is what would have been the switch live coming from the original light switch. Let's test smartphone control. That works. So let's test smart speaker control. Okay, turn on the outside lights.
Okay, turning on the outside lights.
Okay, turn off the outside lights.
Okay, turning off the outside
Okay, so we know it works. So let's try and put this into the switch box behind the light switch and see if it all fits in. So as you can see, I made a little mock-up of a light switch and a light fixture, a very ugly light fixture if I may say so. And as you can see, it works perfectly. And we have Google Home Control as well. Turn on the outside lights.
Got it. Turning the outside lights on.
And we can of course turn it off with the switch as well. So if we take a look inside, you can see that we've got our Sonoff and we've got only 2 wires, no neutral. So we've effectively converted our Sonoff into a no neutral smart switch with minimal amounts of components and absolutely no soldering. Proof that you can use a Sonoff Mini without a neutral. Now, I wanted to keep this circuit absolutely as simple as possible, but I thought I had to mention that it is possible to make some improvements to the circuit operation and to add a bit more safety features to the circuit, and it'll give it longevity as well. So one of the obvious things that this circuit is lacking is some form of short circuit protection or overcurrent protection. You're simply relying on the circuit breaker in the fuse board to trip. But I think adding a type of inline fuse is a good idea, and something that works even better in this case is something called a fusible resistor. And this will take some of the stress off the diodes and components like the capacitor that doesn't like inrush current too much. And this resistor has a dual function. It acts as a fuse and it limits the inrush current to the capacitor and the diodes. Now, if you don't mind soldering, you can do a much better job by soldering some fly leads onto the components, individually shrinking some heat shrink tubing on them, and then shrinking tubing over that to make it into one unit. And I think that makes a much nicer job and a much safer and more professional job. I definitely think adding these flexible wires to the modules will definitely aid the installation into tight spots. And adding the fusible resistor is a good idea, definitely increases safety a lot. Right, next I want to give you one of my top tips for building experimental mains powered circuits, is to use a old-fashioned incandescent light bulb. Now I know they're hard to get hold of. This is an old one that was salvaged before everything switched to LED. And it's kind of hard to buy them nowadays, but they're still about. And what you do is you put your mains line or live voltage in line and pass it through the light bulb. And it acts as a current limiting device. And if there's any short circuit or fault in your circuit, instead of your components blowing up and going bang, it's just the light bulb that lights up. So it really can save your day and stop you making any nasty mistakes, and it prevents the magic smoke from leaving your components. So what you effectively do is you take a lamp socket base and you wire it, you take a plug and you wire your live through the light bulb to power your device. And that way, when it's powered, it passes enough current to power your device. The light bulb passes enough current to power your device. But if there's any short circuits, worst thing that'll happen is the light bulb lights. So really a good way of protecting your circuit. So that's my little handy tip. The old current limiting light bulb or short circuit protecting lamp. And that way, inevitably you will make mistakes. You only need to get one diode in the wrong position with this circuit and something will go bang. All the polarity of all the diodes and capacitors need to be exactly right as in the diagram. So testing your circuit via this light bulb is basically a must. Of course, after you've proven that the circuit works correctly, you can take the light bulb out of circuit and you can do the proper installation. This is only just for testing purposes. Well, as promised, we now arrived at the part of the video where I finally explain how this damn thing works. As with most no neutral circuit designs, the light bulb normally has some sort of bypassing circuit to bypass some of the current back to the device you're trying to power to give it a type of virtual neutral. Normally they use a capacitor, but in our case we use diodes to bypass. And we don't bypass the full AC all the way back to the Sonoff, only half cycles of the AC. And if you see, we have basically two halves of a full bridge rectifier. One half is kind of sitting at the light bulb, and the other half is kind of sitting at the Sonoff. And what we're doing is we're kind of sending the top halves of the AC waveform through the relay of the Sonoff Mini to power the light bulb, and the neutral's bottom halves of the AC signal waveform is steered back through the diodes, and the diodes steer that neutral signal back to the Sonoff so that it gets its neutral that way. So it's not magic, it's only electricery. So let me know what you think, boys and girls. Do we ditch the neutral wire? Do we buy a different smart switch that can work without a neutral? Do we buy a new house that has a neutral wire behind the light switch? Do you think it's a silly idea? I mean, I've got plenty of these Sonoff Minis, and you might have some as well, and you might want to try this just because it's an interesting experiment to try. So let me know in the comments, and I'll see you on the next one.